Endgame's converged endpoint security platform is transforming security programs, their people, processes, and technology with the most powerful endpoint protection and simplest user experience, ensuring analysts of any skill level can stop targeted attacks before information theft. Endgame unifies prevention, detection, and threat hunting to stop known and unknown attacker behaviors at scale with a single agent. For more information, visit endgame.com.
The average time between being hacked and realizing you've been hacked is 1 year. Can you afford to let an intruder roam your network for that long? Can your company weather the fallout when this comes to light? Black Hills Information Security can find the bad guys in your network and train you to do it yourself. Email consulting@blackhillsinfosec.com to find out how a hunt teaming engagement can help you find a persistent threat in your network.
Welcome back, everyone, to Paul's Security Weekly. If you want to join us on April 1st through the 3rd at Disney's Contemporary Resort, we can quite literally go to Disney World together because we'll be at InfoSec World 2019. Are you coming out with us, Doug?
I don't know. I haven't been asked.
Not yet. We'll see. You got to see. We'll
I
see.
did last year. It was great.
Yeah.
We had a lot of fun.
Hey, any excuse to go to Disney. Come on.
Yeah.
So if you want to join us, I'll be speaking. We'll be doing all kinds of fun stuff out there at InfoSec World, briefings, interviews. We're planning on hacker trivia, so I think
we should
Scott, probably.
Josh, and I broke into a restaurant on top of the Contemporary Resort and filmed a show.
Yes, I remember.
We had some poor hapless Disney employee talked into it. The guy was just sitting there like, "Oh God, it's over."
OS 19-Sec Week for 15% off the main conference or World Pass. Also, we have our proud sponsor, which is Thinkst. SecurityWeekly.com/canary. Make sure you go there, check out their deception technology. They got some free open source stuff, but they've got their product too, which is just a fantastic way to get into the whole deception aspect of security, which if you're thinking honeypots, it's not that. I guarantee you it will be most likely a very integral part of your security program. So check it out, SecurityWeekly.com/canary. Mr. Joff Thayer is here with us. My Joff intro says Corey Finley started his information security career in July. Oh, that's Burgundy reads whatever's on the teleprompter. And then it says, fuck you, San Diego. What is going on?
What is happening in the world?
I'm just kidding. We love you, San Diego. In any case, Mr. Joff Thayer is here for a fabulous technical segment. He's going to tell us all about it while I sit here and drink wine and have my cigar, which is absolutely fabulous, I have to say. My choice for cigar tonight was it was out of this world. I'm very distracted. So I'm going to finish my cigar while Joff does his technical segment.
All right. I'm glad I can help, I guess. Anyway. So I am going to do a brief technical technicament.
A technical technicament.
I'm going to do a brief technical technicament.
This is going to be good.
Yep. Okay, can't even start it, right?
Are you using Windex?
That was a great
Windex. Yeah, Windex and PowerShell.
Somebody needs to slip Joff a Mickey.
Oh, God. Who did that? I'm going to attempt to share screen here really quick. So here we go. Start sharing.
I almost made a Cosby joke there, but I'm not going to.
Yeah, that would be bad.
Too soon.
Oh, come on.
All right, so
you haven't seen the one where he's sitting in
context.
prison going, "Where's R. Kelly?"
All right, calm down, everybody. Here's the context, right? Imagine for a minute that you're inside of a network. Maybe you're actually compromised a network like as an internal pen test. You're on site with a customer. You have access to a console, and you have a PowerShell prompt, just like is on the screen right now. Hey, guys, is there a PowerShell prompt?
Yes, there is.
There
okay,
surely
brilliant.
is.
Okay, fantastic. And let's imagine this, that you have a pretty tight environment that has good IPS deployed and good endpoint security deployed, and you want to get a payload down into this PowerShell script. One of the ways that you can do this is actually to get a payload into PowerShell without putting anything on the disk. And not putting anything on the disk is, well, kind of desirable, because if you, there's sound effects, I'm really weirded out. If you don't put anything on your disk, with any kind of activities in pen testing, you will probably not run into the problem of endpoint defenses actually firing some sort of signature. One of the things you can do in PowerShell is actually create a web client using the system.net.web client class in PowerShell. We actually have to type the syntax correctly by using new object. Oh, net object. Wow, the gin's talking here. And then system.net.web client. What I'm doing there is actually assigning to this WC variable an instance of a web client, which I can then use to potentially download payload. Now, let's imagine we're also in a scenario where we have a perimeter web proxy. If we have a perimeter web proxy, we can actually do something like this. If we are dealing with a credential proxy, watch Joff screw this up. Actually use the credential cache provider. Oh, come on, Joff, you can do this. To give yourself the default network credentials of that station. So you can go through that perimeter proxy with the Windows credentials of that station by setting the proxy.credentials attribute of that web client object that you just created. Now, if we want to download a payload, we can actually use wc.download string and then present for ourselves a URL. So I'm going to use something internal to my network. And this is going to be, I'm going to download a PowerView script that is base64 encoded. But before I do that, I need to base64 encode it. So let me go over to the Linux system that is running the payload, and we'll be running the web server shortly. To base64 encode PowerView.ps1, we can use base64, not just base, -w0 PowerView.ps1, and then output that to something like pv.txt.
Hey, Joff, what is the dash
pv.txt? Go ahead.
What does the -w0 do?
Oh, very good question. -w0 makes sure that you are not putting any line feeds in the base64 encoded payload. If you don't use W0, it'll come on, Joff, English. It'll comply with MIME standards and actually put line feeds after every 80 or so characters.
Yeah, don't start speaking Australian on us.
Yeah, I know, right? Now, what if we want to run ourselves a web server really quick? Well, this is where Python it becomes really handy here. We can use the Python simple HTTP server module on port 80 to just simply run a web server that listens on this system, and it will deliver a directory index of everything that's in that particular directory that you're running it in, and it will also deliver any file. So if we run this, we're listening on port 80 on that Linux system. We go back to our PowerShell, and we can now download this pv.txt.
Joff, are you doing all these commands from memory?
Yes, sir. If you look at pv.txt, you'll notice it's a great big base64 blob, right? Anyway, just to refresh that command, that's what we did. The next problem we have, though, is we need to decode the base64 encoded PowerShell script to make sure that we can then put it in memory. Well, here's what we do. We use the system.text.encoding module in PowerShell, use utf8.getString, which actually takes that byte array and turns it into a string, and then we use system.convert from base64 string.
We forgot a B. You're almost there.
Yeah, I got to type it correctly. From base64 string, and then that payload variable that we created with the download. So you see how I used $P there.
I saw your P.
All right, roger that. So now we have a decoded PowerShell script in this variable $SC, okay? So now we have that. How do we actually bring that applet into memory? Well, we can use IEX, which is the interactive interpreter in PowerShell, for that variable, and we basically have run that script at this point.
So you just shoved that payload right into memory after you base64 decoded it.
Damn straight I did.
That's hot.
So now I've
That's hot.
downloaded the payload directly into a variable in PowerShell memory and put it directly into this PowerShell interpreter instance. And this thing has not touched disk at all.
That's hot.
Now, Paul's getting warm. Now, if we want to do something like invoke ShareFinder is part of PowerView. We can actually invoke it. It's already in memory, and we will do it on my network, and you'll see some internals of my network, maybe, but it'll actually run the applet, okay? So you can see various shares in my network, which, I don't know, kind of sucks. But anyway. All right. But if you're in a bigger environment, you probably want to do something like this because the advantage is you are not dropping this payload to disk at all. You're bringing it down into memory and you're golden.
Yeah, I was going to say, why didn't you just write it to a file? Oh, never mind.
Yeah. Right, Paul?
Got it. I got it.
Let's take this concept a little bit further, right? There is another really awesome PowerShell applet called resolve DNS name. Okay. If we use resolve DNS name, we can resolve a name such as, I don't know, www.securityweekly.com, right? And that'll use the listed resolver on this system to resolve a DNS domain name and give you the appropriate answer, which in this case is the IP address of the Security Weekly website. Okay. Well, let's take this a little bit further. What if
it's an information leak, Joff? Everyone can see who our name servers are. Never mind.
Yeah. Okay, Paul. Go back to your memes.
Go home, Paul. You're drunk.
Let's take this a little bit further. I had a situation recently where I was in an environment where downloading from a web listener was just not possible. So I couldn't pull this trick where I ran the Python simple HTTP server. All right. So I thought, hey, let's bring this payload down using DNS TXT records and put it as a DNS zone. So I created a DNS zone, and in this case, it's joff.life, which contains TXT records that have base 64 encoded PowerShell
Oh,
scripts
you're so clever, Joff.
Shove that payload in there.
I shoved that payload in there, right? And what I did was I created one record called PV, which has the number of records that are going to be in the blocks of base 64 encoded text.
See, here I thought I was nerdy with my binary scarf and my R2D2 French press, but here Joff is creating indexes and TXT records in DNS. So nerdy. I'm very turned on right now, Joff, just so you know.
Yeah, he is, let me tell you.
It makes you really hot. It really does. So what you're looking at on the screen right now is a bind9 zone file. Okay, so bind9 is a very commonly used Unix DNS server. It is so widespread. It's probably the predominant DNS server. Thank you, Paul Vixie, on the internet today. Okay, so I used the script, Python script, that created this DNS zone file. And then I loaded it into my DNS server that serves up my domain, which is literally called joff.life, because I'm kind of egotistically nerdy.
Nervy and nerdy. Yep. Got it.
So let's go back to PowerShell and look at how we can actually pull a DNS record. Let's start with resolving the name of zen.joff.life, which was one of those DNS records. Okay. And we absolutely, totally fail because I didn't actually resolve using the type of this DNS record, which is TXT. Now, notice when I resolve with the type TXT, I get the result, which includes the base 64 text that I'm looking for. Now, what I want to be able to do in PowerShell now is decode this base 64 text, but I need to be able to select portions of this with PowerShell. So first of all, I need to say where object section EQ answer. So I get just the answer portion. And then I need to select and expand the object property of the strings which contains the actual base64 text over here. And when I do that, I end up with just the base64 encoded text of that DNS record, okay? So that's really cool. So now what I can do is combine a few concepts, right?
Wait, hold on, Joff. You had an entry in the text record to tell how many or how long the string was. Did you use that here or?
Okay, good question, Paul. I'm starting off with a record I called zen.joff.life, which is actually a single record up here, just to demonstrate the concept.
Gotcha,
then I'm going to move on to this record blocking idea.
Nice.
Okay? All right. So I can pull out the base64 encoded text. So I'm super happy about that. Now, what I want to do is assign that to a variable in PowerShell. So I could say $A equals resolve DNS name, type txt, the actual name, where object section equals answer, and select that property of strings. And now in the $A variable, I now have the base64 encoded text. Now, just like before, we can actually say system.text.encoding UTF, if Joff could actually type, get string system.convert from base64 string and my text, okay? And when I do that, I get the actual decoded text, and it is Security Weekly Zen. The noble-minded are calm and steady. Little people are forever fussing and fretting, by Confucius, okay? So now I have downloaded what could be a payload from DNS, which is kind of difficult to stop. There are very few environments that don't employ DNS, right?
Joff, what if I'm looking for base64 encoded strings in all of the packets traversing my network? Is that way too many false positives as I've experienced in the past, or do you find that people, like, it's not worth it?
So I would agree with your statement there. That is way too many false positives. Now, what you will see, though...
Although, hold on, Joff. Wait. My other thought was, what if I would just look for that in DNS traffic? Probably more anomalous.
Exactly.
I didn't mean to crap in your oatmeal, but anyway.
Yeah, that's exactly where I was about to go. But not only that, if I extend this concept into decoding an entire payload of a PowerShell script, which I'm about to do, then you're going to see some 6,000 to 7,000 DNS TXT record requests happening in a very short period of time.
Also anomalous.
Which is going to be very anomalous, and it is going to be picked up, frankly, by products such as Active Countermeasures, AI Hunter, as potentially anomalous traffic, and many other products in the industry.
And as it should,
Yeah, as it should. Okay, so let's actually take it a little bit further. Let's grab our number of records that we need by selecting, instead of zen.joff.life, we're going to select pv.joff.life, and then we're going to decode it. And what we get is something that doesn't even look like anything at all, which is really bizarre.
Was the number encoded, or was it a straight number?
It was a straight number. I don't know why it did that. What did I do wrong? Well, let's just go to the next issue. I'm going to go and...
Bless you.
Thank you. Sorry.
Yeah, bless you.
Couldn't hit my mute button fast enough.
I'm going to go ahead and loop this. So let's assume that I know the number of records, and in this case, I know that it's 0 to 7,862. I can resolve each of the individual blocked records in the DNS zone to give me the original base64 encoded content. If you remember, in my DNS zone here, we had PV0, PV1, PV2. If we keep on going down in this DNS zone, it goes all the way up to 7,000 something or other, right? There's a ton of TXT records here. Okay. So if I resolve those consecutively using a PowerShell loop, I'm saying 0 to 7,862 for each, basically. Resolve DNS name, type TXT, that particular PV record with the index number attached to it with the $_ where object section equals answer, and select expand property strings.
Oh, wait, Joff. I got it. So basically you do this and it grabs it, right? But if you were to put this in a for loop and put a sleep timer in there and make this go over the course of 24 or 48 hours.
Yeah.
Yeah. Is that where you were going? Were you going to go there? Please tell me you were going to go there.
I was going to go there, but initially you can see that I'm getting the base 64 encoded content very rapidly here and with repeated DNS queries, right? Now I could write, as Paul just suggested. Actually, I wasn't going to go there originally, Paul, but you went ahead and played into it. So as Paul just suggested, I could write some code that did this with a random delay between each DNS record.
Random delay.
Slowly build it.
Yeah.
And slowly build it. Now, I need to assign it to a variable. So let's assign it to a variable. We're going to call it payload. And we just let that run. So now we are querying some 7,862 records, right? Until we build the entire payload in base 64 encoded format into this variable P, okay? And I probably should have chosen a shorter PowerShell script. But
6 weeks later.
So Joff, while
next week on Security Weekly, when they when it finishes,
listen to the music in your head. Okay. So actually, it really does illustrate a good point. Even without a delay, first of all, I'm issuing 7,862 DNS requests of type TXT for an incrementing block number.
That's a lot. Yeah.
Pretty obvious. Okay. If you're looking. But
if you're looking for that.
I'm depending on the DNS protocol to actually do its job with a zone Joff.life, which is hosted across the internet. And, well, let's just say that it's not going to be really highly performant, right? It's going to take a while for these DNS queries to complete.
And Joff, because it's UDP, do you notice that something doesn't get delivered, or does the DNS protocol take care of that in upper layers?
Very good question. So the DNS protocol, we hope, is going to take care of that in upper layers. The other thing to recognize, Paul, is that by RFC, the TXT record type in DNS can be up to 255 characters long. Mm-hmm. If you add the 255 characters as your blocking factor, and you also add in the authoritative DNS name server information, and whatever else cruft is going to be in the DNS record, you might come close to 512, but I don't think you're going to exceed it, meaning that you're going to stay in the world of UDP. If you exceed 512, as most of our listeners know, and you guys know as well, you're going to renegotiate DNS over TCP.
If this was a TLS supported DNS connection, as is becoming more popular now, does that would run over TCP, correct? It would
correct,
it would have
and you wouldn't be seeing the traffic unless you were TLS manning the middle.
And that's what Eric was talking about earlier, was blinding yourself.
Right.
So now you couldn't see it if it was running under the TLS.
Right.
Exactly.
I mean, you could see it, but you wouldn't know what it was. It would
Google
just be
on their DNS servers just now supports.
Yeah, it would
TLS.
be encrypted, so you wouldn't see what he was downloading.
Yeah.
So in short, to conclude the segment, seeing as this is not going to finish before I finish my drink,
it's right on the edge.
That we basically have pulled down an entire PowerShell payload using DNS across the internet, using a technique by encoding the records into TXT records. I simply used the standard MIME blocking, which is about 60-odd bytes for each TXT record. I could have increased the blocking to be 255 bytes, right up to the maximum, thus decreasing my number of records queried, which is obviously more optimal.
255 is a limitation on the TXT record.
That is correct.
Queries in general can be up to 512 bytes, and that's for the payload, right, before it switches to TCP.
Right. You've got to understand that TXT, the 255 limit with the TXT type record is the limit of the resource record payload itself, not the payload of the DNS packet.
Was it 512 or 384? Why does 384 bytes sound like it was something?
I
just
don't know.
haven't
but
thought about it in a while.
You could drink a little more and maybe it'll come to us.
Yes.
Yeah. Anyway, the technique beyond this, once that payload comes down, is, there we go. We got it. We can go ahead and use this same technique here to convert the payload from base 64.
Yeah, make that a P. You got to put your P in there.
Yep, got to put my P in there, and I'll call it shellcode. Okay, and then we do IEX shellcode, and then we have invoke ShareFinder again. It's in memory, and we're off and running. Okay, and we have pulled the payload down across the network using DNS instead of HTTP with some fairly simple PowerShell tricks.
And your code, Joff, just looks for open shares or shares on the network.
Yeah, invoke ShareFinder. It's not my code. It's part of PowerSploit. It is the PowerView module in PowerSploit.
Okay, so you took it out of there and
Yes.
encoded that. I gotcha.
Yeah. And that's the end of my tech segment. I really just wanted to show you some tricks in PowerShell that you can use to get around some pretty severe network restrictions that you can run into when you're pen testing. And these are relatively simple techniques. You do have to have some knowledge of bind. You do have to have some knowledge to create that DNS zone file and manage your domains. But beyond that, the PowerShell portion of it is really not too complex.
And you could do this over TLS, and you could randomize, like Doug was saying, download it in chunks, but randomize the chunks. Yeah. And that would ensure that you got your payload both reliably encrypted and fly under the radar. Well, potentially, right?
Absolutely. The extension to this, the logical extension, which I am definitely working on some code that Black Hills will be using, is to not only encode the payload, but also to encrypt it before encoding it. So
I was going to ask you, Joff, can you set a forced TLS encryption for those two ends?
Yeah, well, there's a couple of things, right?
DNSSEC,
you're not going to be able to force. You're not going to be able to force the DNS infrastructure to encrypt, but you can encrypt the payload in the TXT records, so that when the security solution decodes the TXT records, they're just going to get encrypted blocks, and they're not going to be able to do anything.
And you could encrypt what you're putting in manually, even, and then put the decryption on the PowerShell side.
Correct.
Yeah, so that the text itself is encrypted. It won't matter if they see it or not. It just looks like a bunch of garbage.
That's right.
Yeah,
that's right.
You could put the key in your PowerShell script.
Mm-hmm.
You could, or you can use some sort of environmental keying option.
Yeah, but I was just thinking low end. So.
Yeah. So that's just a little bit of pen testing fun that I wanted to show you tonight. It's something that I've used actively. That's been relatively successful. It definitely does not touch the disk and allows you to have some customization in the way that you're bringing payloads down to the network. So I think it's a really handy thing to know.
Thank you very much, Joff. Now, are you planning a blog post on this or any follow-up information?
Right now, I'm not. I probably will do a blog post in the future. There is the same technique just for pure download, not with DNS, was actually mentioned in the Cash Cow tipping webcast that Black Hills recently did. The DNS blog post is something I still have to write.
Well, if you go to securityweekly.com/BHIS, that's securityweekly.com/BHIS, I will be certain to put this technical segment there and any other information that I can coerce out of Joff, including a link to his blog post when it is published. You go to the one easy website for BHIS, that's securityweekly.com/BHIS. Thank you very much, Joff. With that, we're going to take a short break, come back with the security news for this week. Stay tuned.